During the COVID period, cancer was a significant risk factor for severe COVID and mortality. And so the expectation would be if people who were at risk for cancer or had cancer had higher mortality associated with comorbidities, we should see a significant fall off in cancer presentations. What would you say if that wasn't necessarily the case? In reality, it seems that some cancers are increasing and others are decreasing. What is going on? Well, what's interesting is that I've got the data from Norway, and Norway is quite rigorous with regards to its standards on cancer and anything to do with health. And so I've got a huge data set that I've gone through and I've tried to put it in a context that would make sense to you. And this is the annual report from Norway, Cancer in Norway 2025, Cancer Incidence, Mortality, Survival, and Prevalence in Norway. Because many people are still arguing about, well, is cancer still an issue with regards to the post pandemic period? You would have heard the term about what we call turbo cancer, and that's in the background for a lot of people with regards to whether or not this is an issue. So, some clinicians, some academics took this detail to say that, well, there is no longer an issue. This cancer information didn't show any significant rise in relation to vaccinated cohorts, and so therefore this is irrelevant. I tend to look at it a bit differently because what we're seeing is not so much no change, but the fact that we should have seen a decrease, and we saw it in some sections, but an increase in others doesn't seem to make sense. And so, what I'll be trying to see if I can put together is exactly what I think the mechanism is as to why these patterns are occurring. Really important point. What really is going on, and how does it fit with what we're seeing? So I've put together a whole dashboard because I have access to looking at the UK hospital admission episodes and trying to analyze whether or not this is relevant as well with regards to the UK. And so I'll be coming to this in a little bit, but looking at the cancer trajectory, and it's comparing what's happening with Norway and what's happening with the UK. And this is the most important one when we look at the differences in which cancers went down in Norway versus the ones that increased in the UK. This is part of the important discussion about what exactly is going on. Additionally, I have broken it down into all the details about which cancers are increasing and decreasing based on Norway. So here is what it's broken down with. And this is the important bit that we are saying with regards to what is happening. Why are some decreasing and others increasing? That's really the question that I have. So when we look in detail here, you can see that cervical cancer went down by 21%. That's the highest fall. Lung cancer makes perfect sense because so many people with lung disease died during the pandemic. Uterine cancer, prostate cancer, and again, this is likely to be connected with comorbidities in the pandemic more so than anything else. But look at the increases. Non-melanoma skin cancer, 20%. 13% male and female. This is males, 13%, females, 20%. Melanoma, 13% in females, 11.9% in males. Thyroid cancer, 11.4%. Breast cancer, 10.5%. So this is affecting cohorts who are younger, most likely. When we look at the decreases, very often this is likely to be affecting older comorbid individuals. And then that would make perfect sense as to why we're seeing this change in trajectory. Here is where I go into what my research has been suggesting. I'd made a presentation on this some time ago, and this is just some general principles as to why I think that this is happening. essentially, there is something called CD147, and I've done a few presentations about it. And it's a very unusual thing that we only recently came across. And here are some slides to try and explain it. When we look at what happens to a cell when it is infected by through ACE2, so this is the virus, it uses ACE2 to get into the cell. What it does is that it upregulates another entry portal, CD147, and the virus can also use this to get inside the cell. So it accelerates infection in cells that are already infected. Now, you may think on its own that that's no big deal. The problem is that in cells that already have CD147, this means that you have accelerated infection in this kind of cell. Now, that's really what makes it very, very different. And so when I did an image as to what I thought this was like, is that it would look something like this. This is the cell, it's a castle. This is the ACE2 entry, but there is a backdoor, CD147. This allows the virus to get inside the cell and then infect it. And this then causes the virus to take over the cell. Now, again, you may ask, what really is the connection with regards to cancer? Because that's then the other part of the problem. Where does cancer fit in this picture? Well, one of the interesting things is that there are certain cancers that already have CD147 on the surface of the cancer cell. And it does an important role because this CD147, when it's on a cancer cell, it helps the cancer cell to become more invasive. It breaks down tissues, helps to get it to blood vessels and get spreading across the body. And this is one of the cancers that does this especially well is melanoma. And this is why melanoma tends to spread very early. And this is where I'm trying to explain to people that you have to look at the characteristics of the cancer. So when you say turbo cancer, you make it sound like the cancer is growing faster. And this will be discounted by people who are in the scientific community who are stuck in the narrative that there is no problem. What you have to say is that post-pandemic, more cancers are behaving like a melanoma. A melanoma cancer spreads very early. And this is simply because it uses that CD147 to break down the barriers so that it can get to the bloodstream and spread to distant organs. Because what people are calling turbo cancer is not necessarily that the cancer is rapid. It's just that when they hear of family and friends who have cancer, they are told it's already stage 4. It has already metastasized to the liver, to the lungs, to the brain, to the bone. And so that person is no longer able to have curative treatment. And this is what causes the shock when you hear the news and you go, oh my goodness, so and so is told that they've got cancer. It's not just that they've got cancer, it's that they've got cancer that has gone beyond the curative stage into palliative approach, where all you can do is chemotherapy and radiotherapy. That's the bit that people tend to call turbo cancer. But it will confuse the scientific community, who will then discount it if you say it. So I am saying to you, say it in a different way. It seems that more people are having accelerated cancer, and more younger people seem to be having a diagnosis of cancer. Those can't really be refuted because this is what the data says. So again, when we look at the data, and I'm going to show you here now, I'll see if I can make this big enough for you to see. When we look at the comparison, because I then took this data and looked at the UK data set from 2016 to 2025, put them together to try and make sense of it. And here is what we're seeing. When we look at the cancer groups, again, cervical cancer had the biggest fall in Norway. So Norway is in green, the UK data is in blue. You can see this big fall in Norway, slight rise in the UK. Here you have significant falls for prostate, uterine cancer, lung cancer. In the UK, these seem to be rises. Now, these are not exactly measuring the same things because this is measuring hospital episode statistics. This one is looking at the whole population, but the principles of the trends are still important. When you go down to melanoma of the skin, breast cancer, brain cancer, that's central nervous system, you can see for Norway, it seems to be neutral, which in reality means an increase because there should have been a mortality death. But you can see here that for all of them, they're both rising in the same direction. Skin cancer, breast cancer, brain cancer, thyroid cancer are all increasing in both populations. This is what I'm talking about when I talk about CD147, because these are the cohorts that are likely to have CD147. So again, I took my platform, and this is why I'm saying to people, if you want access to this platform, this trajectory, I am building it out slowly, step by step. This will be added looking at the cancer pictures. I've already looked at cardiovascular, I've looked at neurology, I've looked at liver, I've just done renal, I've looked at immune privilege. This is cancer now being added. Over time, this is going to be a cohort of dashboards that for people who really want to understand what's going on, you will have data in front of you that no one can argue with. And it's simplified. And so in this case here, this is going to be again there. I looked specifically at CD147 type cancers. And when it looked at that, you can see all of them are showing a rise, a strong rise, a 21% rise for CD147 related cancers. And this is what I'm saying is that you can see strong CD147, that's kidney cancer, skin cancer, liver cancer, breast cancer, all of these are rising. And so what I'm saying is that it seems that we are in a situation that is causing some difficulty. I think that this issue with CD147, I did a full presentation on it, and I'm going to get you some of the images that I had used previously with that, because this is very important for you to understand what exactly is happening across the population and why it seems to be such an issue. My concern is that if we don't look at this, if this is not addressed, what then happens is that you end up with a broad risk to the population that can't easily be handled and resolved. That's the bit that I think is so very important with regards to what is going on. So I'm going to show you the work that I had done specifically in relation to CD147 and the impact that this is happening with regards to cancer. So here are the slides that I used. This is just showing you a cancer cell. And in this case, this cell is supposed to have CD147 on the surface. So it can then get infected by SARS-CoV-2. And this is why people make the mistake of thinking that this is specifically related to vaccination, COVID vaccines. Now, I've already covered since 2022 that there are certain risks that are associated with that. But this one, I want you to think about it in a different line of principle. Just work with me here, because this, I think, is the really important point. So when this cancer cell gets infected, what then happens, it further upregulates CD147. So you have more virus able to come in, but critically, in cancer cells, these CD147 portals or entry points have a very important role for the invasiveness of the cancer. So what happens is that these cancer cells, because they don't use the mitochondria, they tend to just burn through glucose, and then they have too much lactate inside the cell. And so if they can't get the lactate out, they can't grow quickly enough. And this is therefore what the CD147 does. It allows it to export the lactate. The lactate will make around the cancer cell acidic, which breaks down the matrix, suppresses the immune system, drives blood vessel formation, which will increase the risk of metastatic spread. This is such an important principle. Again, I'll use an image to show you here. This is what I call the cancer cell that has become infected, and there is no way to easily get rid of this because this cancer cell is already evading the principles of dying, so it will become almost permanently infected. It then drives these cells to produce lactate, which then increases their speed of replication and makes them spread better. This is why, based on the data, I am not surprised that the cancers that use CD147 are the ones that are spreading or growing fastest. Again, this is the image of a melanoma. Melanoma stage 1 just looks like a little mole. At this point, you have to take it out. By stage 2, it's starting to break through into the dermis. Stage 3, it's starting to go to a lymph node. Stage 4, it's spreading. And what can happen is that you barely notice that this is actually a slightly bigger mole. And the point is that this is the characteristic of melanoma, is that it does this part exceptionally quickly. That is what people are calling turbo cancer. But in reality, it is like a melanoma growth of the cancer. So in summary, just to get back to our points, what we have here is a situation where we have a number of cancers that are clear understanding as to exactly what that mechanism is. Here are the numbers. If you hadn't seen them before, this is what it looks like for the Norway cancer trend. Decreasing cervical cancer by 20%, lung cancer by 10%. You can see all the way down, even colon cancer is decreasing in Norway. But conversely, they have all of these cancers increasing. And so overall, there is still an increase in cancer, even though a lot of people have died, what I call the mortality death, which should theoretically mean all cancers therefore have gone down. That's not what we're seeing, even with the data in Norway. We have the same problem in terms of the UK. When we look at the cancers and we compare them to Norway, here is what it looks like. These are the Norway in green ones that have gone down, but the biggies that have linked to CD147, skin cancer, breast cancer, brain cancer, thyroid cancer, all of these are rising in both populations, just higher here because it's a slightly different measure of the disease. This is pretty serious stuff. It's not meant to make people afraid, but what you don't do is just let them ignore it. Because at the moment, I have to appeal to the public to start asking harder questions. Don't just take it that you know it. You know your family members. You know all the friends you're hearing about. And you keep on wondering to yourself, am I imagining it that my co-workers, friends, family, so many more people seem to be having cancer? Is it just coincidental? The problem is that everybody is thinking the same thing. We need harder questions. You know that the data is out there. We have to almost force the epidemiologist to actually analyze this data. This is why, for me, I started doing it. I got tired of people telling me there is no evidence. And I'm saying, I am telling you, I am hearing it over and over again. Something is wrong. That's why I started to use detailed analysis to get the answers. If you are interested, please follow in the links, because this information is going to become exceptionally valuable in months and years to come. I'm just building it out at this point. Everybody should be aware, everybody should be educated, and critically, this is how you are then able to help other people to understand this is not in your head. This is actually real information. So, again, thank you for being with me. I appreciate the support. Remember to like, to share, to subscribe. All of it will be beneficial to me in the long run. Have a great evening.